Hello, today we're looking at assignment 19 from the STEP support programme. So this question's got a couple of different parts which are connected. It's all about the equations of some paths which obey certain conditions. So let's have a look at the first part. Okay, so this part is saying that point A has coordinates 5, 16, and B has coordinates minus 4, 4. And we've got another point that moves such that this relationship is obeyed. So if we had 2 points, A and B, and the point always moved, so it was the same distance from both of them, you'd end up with the perpendicular bisector of A and B. But in this case, the point's moving so that the distance between A and P is always twice the distance between B and P. So it could be something like that. So the question is, what sort of shape does that make as the point goes round? So let's get rid of those and let's do some of the algebra. Okay, it's a bit easier. So instead of doing AP equals 2BP, if instead we do AP squared equals 4BP squared. So not forgetting to square that 2 as well. So the distance between A and P all squared is x minus 5 squared plus y minus 16 squared. So that's just using Pythagoras' theorem. The distance between B and P squared is x plus 4, because it's minus 4 squared, plus y minus 4 squared. And then we have this 4 on the outside. We want to show that it has this form. So we're going to have to get our hands a bit dirty here and do some algebra. We end up with x squared minus 10x plus 25 plus y squared minus 32y. 16 squared is the same as 2 to the power 8, which is 256. And then on this side, we get 4 into x squared plus 8x plus 16 plus y squared minus 8y plus 16. Okay, a little bit more work. We've got x squared minus 10x plus y squared minus 32y. Actually, I won't actually deal with that for now. On this side, I've got 4x squared plus 32x plus 4 times 16 plus 4y squared minus 32y plus 4 times 16. Okay, there's a reason why I've left it like that. We've got a minus 32y on both sides, so those can cancel out. And another thing to notice is that 16 squared is the same as 256. So I might be able to use that to help me. I'm going to take all of these parts here and take them over to the other side. And then I'm also going to swap sides. So I'm going to have 4x squared minus x squared gives me 3x squared. I've got 4y squared minus y squared is 3y squared. I've got 32x plus 10x. So I've got 42x. The y term's cancelled. And then I've got 8 lots of 16 minus 16 lots of 16 plus 25. So that's this thing and this thing give me 8 lots of 16. And I know that 256 is 16 lots of 16. So this is going to be 3x squared plus 3y squared plus 42x plus 8 lots of 16 minus 16 lots of 16. Oh, this one should be a minus. Is the same as minus 8 lots of 16 minus 25. And let's just work that out. 8 lots of 16 is 16 multiplied by 2 by 2 by 2. So I go to 32, 64, 128. Add on the 25. That gives me 3, 5, 1, 153. So I've now got 3x squared plus 3y squared plus 42x minus 153 equals 0. Now, it would be nice if we could divide by 3. If you haven't seen this before, you can check to see it's divisible by 3 by adding up the digits. 4 plus 2 is 6, that's divisible by 3. 1 plus 5 plus 3 is equal to 9, that's divisible by 3. So we can divide by 3, x squared plus y squared plus 14x, that's meant to be 14. Actually, this is quite easy, it's divisible by 3 because 150 is 50 and 3 divided by 3 is 1. Okay, so we've now got that. So it's not quite in the right form yet, but we can do some completing the square. So looking at the x squared and the 14x, that's the same as x plus 7 squared minus 49 plus y squared minus 51 equals 0, which gives us x plus 7 squared plus y squared equals 100. And a little square just means end of proof, or you could write as required or anything like that. Okay, so we've done the first part of the question. So let's have a look at the second part. Okay, here we have a different curve, and this has now got a lot more variables in it. So the first part of the question was quite concrete. We had lots of numbers. Now we've got some points A, B, and we've got a K coming in. But we're going to start in the same way as before. So if we multiply, if we square both sides, so we get QC squared equals K squared QD squared. Okay, QC, so the distance between Q, which we'll say has got coordinates x, y, and C, which is A0, is going to be x minus A squared plus y squared. And because we're looking at the distance squared, we don't need to bother with the square root. And then this side, QD, is x minus B squared plus y squared. Okay. It says, given that the path of Q is the same as the path of P, show that that is true. Well, let's start by simplifying this a bit if we can. So we're going to get x squared minus 2ax plus a squared plus y squared equals k squared into x squared minus 2bx plus b squared plus y squared. Now the question says that k is bigger than 1, so I'm going to take all of these things over to this side. So I'm going to get k squared minus 1 x squared plus 2ax plus k squared minus 1 y squared. Oh, I've missed something out. Minus 2bx. So that was adding on the 2ax, and we've still got, and that's actually got a k squared in it as well. I'll tidy that up in a second. So I've dealt with the y squared, and then we get plus b squared k squared plus a squared. So just tidying that up a bit. K squared minus 1 x squared plus 2a minus 2bk squared x. So that's from this term multiplied by k squared, and then with that term added on, plus k squared minus 1 y squared plus b squared k squared, and that should be a minus a squared. Okay, I'm pretty happy now that that is now correct. So it would be quite good if we could compare it with the one before. So what I'm going to just do is I'm just going to delete some of these parts. I'm going to try and delete some of these parts so I can get the next thing on. There we go. Okay, so there's the part that we've just done previously, which is x plus y squared, sorry, x plus 7 all squared plus y squared equals 100. So that's the path of P, and we want that both of these parts to be the same. So let's Yeah, I think probably eraser is going to be easier at this point rather than trying to select and delete. So let's have a quick think about this. This is the path of P here. This is the path of Q. And we want both these paths to be actually the same path. Now for Q, we've got it expanded out. I think actually to make our lives easier, it would be a good idea to expand out P as well, so it looks the same. So if we expand out P, we're actually going to go back to where we were a couple of lines before in part I. We get x squared plus 14x plus y squared minus 51 equals 0. Okay, so that's just expanding the brackets and simplifying. Looking at Q, and actually what might be quite a good idea is if I just write these out a bit more spaced out, and I'll show you why in a second. Okay, I'm going to take my equation for Q and write it underneath. So this is why I wanted to space it out a bit. Plus b squared k squared minus a squared equals 0. Okay, so now that I've spaced it out a bit, I've got things lining up nicely. I've got all my x terms lining up, I've got my y terms lining up, and the constants lining up. Now we want both of these equations to be the same, which basically means that this one has to be a multiple of the one before. So we want it to be the fact that this is multiplied by k squared minus 1. Now if we multiply x squared by k squared minus 1, that works. The same works for the y squared. This is a bit more interesting. So what we want is we want 14 multiplied by k squared minus 1 to be equal to 2a minus 2b k squared. And what we also want is we want minus 51 multiplied by k squared minus 1 to equal b squared k squared minus a squared. Okay, so if that is true, then these two equations are actually the same equation. It's just one's been multiplied throughout by k squared minus 1. We want to show that this is true, and this has got no k squareds in it. So it might be a good idea to try and eliminate k squared in some way. So if I take this equation, I get 14k squared minus 14 equals 2a minus 2bk squared. That tells me that 14 plus 2b, lots of k squared, is equal to 2a plus 14. So that was adding the 14 to both sides and adding the 2bk squared to both sides. That means that k squared is equal to 2a plus 14 over 14 plus 2b. Now, I like the look of that because that is the same as a plus 7 over b plus 7, if I divide top and bottom by 2. And that is this side. So I'm fairly happy about that. And looking at this equation, I've got a 51 in there. So that also makes me feel quite confident. So taking this equation, I get minus 51k squared plus 51 equals b squared k squared minus a squared. So 51 plus a squared equals b squared plus 51 k squared. So k squared is a squared plus 51 over b squared plus 51. And then if both of these are true, I've got two different forms of k squared. I can say, therefore, a plus 7 over b plus 7 equals a squared plus 51 over b squared plus 51, as required. So in this question, there's quite a few bits where you're given the answer. And those are quite nice because it means that if you go wrong slightly on one part, you can still do the next part. Okay, so that's most of part 2 done. I'm just going to clear all the drawings and then go on to the very last part, which says show further that this is true. So show further is sort of an implication that we need to use what we've already done. And this is an equation which has got A's and B's in it. So we've got the equation that we've just shown, which is A plus 7 over B plus 7 equals A squared plus 51 over B squared plus 51. So let's try just doing some stuff with that. Okay, so probably the obvious thing to do first is to get rid of fractions, because fractions are a bit of a pain in the neck. Okay, and then let's try expanding that out. AB squared plus 7B squared plus 51A plus 7 times 51, I'm not going to work that out, equals A squared B plus 51B plus 7A squared plus 51 times 7. So the reason that I didn't work that out is I can now just say that. And I didn't actually have to work out 7 times 51 at all, which makes me happier. Okay, so we probably want to take everything to the same side. So we get AB squared minus A squared B plus 51A minus 51B plus 7B squared minus 7A squared. Okay, I think all my signs are correct there. We can notice from here that we've actually got a common factor. So this is AB into B minus A. So we've got a common factor for AB in both parts here. And we can do something similar here. This is 7B squared minus A squared, which is actually the same as 7B minus A, B plus A. I'll just stick that first one in there as well. Now, for this one, it's kind of tempting to just factorize out the 51 like that. But if you notice in these two below, I've got a B minus A factor. So actually, if I just swap over the signs like that, that's meant to be an A, that's going to make my life a little bit easier. So I've now got a factor of B minus A appearing everywhere. So I can take that out as a common factor. AB minus 51 plus 7B plus A equals 0. Okay, this doesn't look quite like the equation that we want to, so it's a good idea to go back to the question and see if there's any information that we haven't used. And actually, we've got this A is not equal to B. So if A is not equal to B, you can divide by B minus A. So if I just say A not equal to B implies that this has to be equal to 0, because we can't have this part equal to 0. Okay, with any luck, we can fit the last bit of working into this part of the question. I'm just going to take this and rearrange it slightly. This is AB plus 7A plus 7B minus 51 equals 0. And now we're just going to have a little bit of a think about something a bit like completing the square, but not quite. So if I imagine two brackets, if I start them with A and B, I'm going to get an AB term. Now, if I put a plus 7 here, I'm going to get a 7A. And if I put a plus 7 here, I'm going to get a 7B. So this pair of brackets gives me the AB term, the 7A and the 7B. It gives me an extra plus 49. So I'm going to have to take that away. And then I've still got the minus 51. And then that means that the final equation looks like this, which is what we wanted. Okay, thank you very much for watching.